Hello everyone, welcome to Study with your Bhai, where we simplify the programming concepts for you. Today, we are diving deep into stack operations, a fundamental data structure in computer science. By the end of this video, you will have a clear understanding of stacks and how they work. So let's get started. First of all, what is stack? Stack is a linear data structure which follows the LIFO principle. Last in, first out. Last in, first out. Imagine a stack of books. You can see here a stack of books where it has a stack top, and if you consider this, we have to get the book from the top only. The book that inserted last should be popped first. So this way it follows last in first out principle. The last in first out concept is used by stack, a type of linear data structure. The queue, which is another linear data structure, it follows two endpoints, but stack only has one, front and rear. It only has one pointer, top pointer. You can see here the stack top. When an element is added to the stack, it always added to the top, and it can only be removed from the stack. To put it another way, a stack is a container that allow insertion and deletion from the end, as it known as the stack top. Now coming to the operations on stack, there are certain stack manipulation operations. Number 1 is push, number 2 is pop, number 3 is top, and then is empty and size. So the push is used to insert an element into the stack. The pop is used to remove an element from the stack. Top returns the top element of the stack. Is empty, it checks the stack is empty or not. Size returns the size of the stack. So in the right side you can see there is a picture of stack where we can see push operation where the data was pushed into the stack, and in another picture that in another stack it was popped from the stack. So this way it follows the last in first out method or principle. Now coming to the push operation of stack. The steps involved in push operation is given below. So let's see the picture. First of all, it checks where the stack is empty or not. If the stack is already full, we cannot insert another element into the stack. So the stack must be empty or half empty. Okay. So we have to check the top is -1 or not. If the top is -1, we can insert an element like this, push 10. So we insert 10 into the stack and we make the top 0. Another element 20, we push it and make the top 1. Then we push 30 and make the top 2. In this way we fill the stack one by one from the top and increment the value of the top. So let's see, before inserting an element in a stack, we check whether the stack is full or not. Okay, if the stack is already full, we say stack is overflown, means there is no space to insert any new element. When we initialize a stack, we set the value of the top as -1 to check the stack is empty or not. When the new element is pushed in a stack, first the value of the top gets incremented from top is equal to top plus 1, and the element will be placed at the new position of the top. the element will be inserted until we reach the maximum size. So here's the handwritten note of push algorithm. Here you can see, first we check if the top is size -1 or not. If it is size -1 means the stack is full. We print overflow and go to the exit statement. Step 2, we set the top as top +1, and then step 3, we give the item into the stack top and exit. Now the next operation is the pop operation. In the name of pop, we can see we have to delete an element from the stack. In the right side, you can see the pop operation. First of all, the stack was full. Then we one by one delete or pop one element and decrement the value of top. In the first picture, we can see the top was 3 and then it is decremented to 2 and 40 was popped from the stack, and then again the top is decremented to 1 and 30 was popped from the stack, and this way the stack was getting empty. Whenever it was fully empty means the top is -1, we cannot get another value from that and the stack declared underflow condition. So let's see the process. Before deleting the element from the stack, we check whether the stack is empty. If we try to delete the element from the empty stack, then the underflow condition occurs. If the stack is not empty, we first access the element which is pointed by the top. Once the pop operation is performed, the top is decremented by -1, like top equals top -1. Now check the handwritten note of pop algorithm. First of all, we check if top is -1. If top is -1, it seems that the stack is empty and we print underflow and go to the exit. Now step 2, if the stack is not empty, then we print the stack top and we decrement the top value, top equals to top -1, and go to the exit. Now the third operation is the pick operation. The pick operation is basically to display the top element. It is used to abstract data types like stack, queues. The function returns the value at the top or front of the collection while keeping the element from the collection in place. Means it does not delete or insert any value, it just show the value in the top. Now check the handwritten note of pick algorithm. First of all, we check if there is an element or not. If there is no any element, so we declare underflow and go to the exit. And if there is an element, so we just simply print the top element and go to exit. Now the last but not the least, display function of this stack. We need to display the stack where here is the algorithm of that. You can see in the first step we check the top is -1 or not. If the top is -1, it means the stack is empty, so no need to display, so it declares underflow. If there is an element, we can see we repeat using for loop, we repeat from top to 0, means from top element to the last element of the stack. Now we print stack I, means the top element. I holds the top element, and we start the loop and continues the step 3, means the printing of elements in the time whenever the stack is empty, it declares underflow. You can see the time complexity of this display function was big O n, because here we use a for loop. Now coming to various types of stack. There are various stacks element. So we can see there are various types of stack present here. Okay, just a second. Number one is register stack. Another one is okay. Let's come to the last but not the least, types of stack. There are various types of stack: register stack, memory stack. Register stack, the memory unit also has a form of stack called register stack that can only handle a tiny amount of data because the capacity of the register stack is so little in comparison to the memory. Its height is constantly constrained. Now coming to the memory stack. This kind of stack is capable of managing a lot of data from memory. The memory stack can be any height because it uses a lot of memory space. Now coming to the application of stack. Using stack we can do different things like converting from infix to postfix to prefix. There are there are redo and undo operations in numerous locations including editors like Photoshop and other tools. We can use stack operation in web browsers forward and backward functions. That's all for today. I hope you have a clear understanding of stack operations, and we will be coming with Q in next video.